National Electrical Code Section 200.7 dictates how conductors must be identified, emphasizing color, marking, or other suitable methods as per Table 200.7. This table specifies that black designates hot conductors, white indicates neutral conductors, and green or bare signifies grounding conductors. Consequently, markings that alter a wire's color to mimic another purpose are generally prohibited. An example would be applying green tape to a black wire to designate it as ground. This is not allowed. An exception exists in Section 250.79d, which pertains to equipment grounding conductors in swimming pool installations, where black conductor tape is permissible. The prohibition against altering wire colors stems from the critical role color coding plays in ensuring the safety and proper operation of electrical systems. Modifying a wire's color introduces confusion and heightens the risk of electrical hazards. Picture a scenario where a black wire is marked with green tape to signify it as ground. If this wire is inadvertently connected to the hot side of a circuit, a dangerous situation could arise. Let's consider a few more detailed aspects. Firstly, the importance of consistent color coding across electrical systems cannot be overstated. It provides an immediate visual cue to electricians and other qualified personnel, enabling them to quickly identify the function of each conductor. This quick identification is crucial during installation, maintenance, and troubleshooting. Secondly, the use of standardized colors minimizes the risk of accidental misconnections, which can lead to equipment damage, fire hazards, and even electrical shock. For example, if a neutral wire, typically white, is mistakenly connected to a hot terminal, it can cause a short circuit, potentially damaging appliances and creating a fire risk. Thirdly, the NEC strict regulations on wire color coding are designed to protect both qualified electrical workers and the general public. By adhering to these standards, we ensure that electrical systems are installed and maintained in a safe and reliable manner. Now, let's delve deeper into the exception outlined in Section 250.79d regarding swimming pool installations. This exception acknowledges the specific challenges associated with grounding in wet environments. In swimming pool applications, equipment grounding conductors are often exposed to corrosive conditions. The use of black tape in this context is intended to provide an additional layer of protection against corrosion, ensuring the long-term integrity of the grounding system. It's important to note that even with this exception, the black tape must be applied in a manner that clearly identifies the conductor as an equipment grounding conductor. This might involve using multiple wraps of tape or adding a label indicating the conductor's function. Now let's broaden the discussion to include other types of wire markings that are permitted or required by the NEC. Firstly, wire markings can be used to indicate the voltage rating of a conductor. This is particularly important in high-voltage applications where it's crucial to select conductors that are rated for the appropriate voltage level. Secondly, wire markings can also be used to identify the manufacturer of the conductor and the type of insulation used. This information can be helpful when selecting replacement conductors or when troubleshooting electrical problems. Thirdly, the NEC also requires certain types of equipment to be marked with specific information such as the voltage, current, and power ratings. These markings help to ensure that the equipment is installed and operated in a safe and efficient manner. Let's further break down the different sections in the NEC related to wire and cable. Firstly, Article 310 covers conductors for general wiring. This article provides detailed requirements for conductor ampacity, insulation types, and installation methods. Secondly, Article 334 addresses non-metallic sheathed cable, commonly known as Romex. This type of cable is widely used in residential wiring. Thirdly, Article 392 covers cable trays, which are used to support and route cables in commercial and industrial applications. Now let's consider some practical scenarios involving wire marking and identification. Firstly, imagine you are installing a new lighting fixture in a residential home. You need to connect the hot, neutral, and ground wires from the fixture to the corresponding wires in the junction box. By carefully observing the color coding of the wires, you can ensure that the connections are made correctly, preventing electrical hazards. Secondly, suppose you are troubleshooting a malfunctioning electrical circuit. By using a multimeter and a wire tracer, you can identify the different conductors in the circuit and determine whether there are any breaks or shorts. This process can be greatly simplified by the proper color coding of the wires. Thirdly, let's say you are working on a construction site where multiple electricians are installing electrical systems. By adhering to the NEC wire marking requirements, you can ensure that all the electrical systems are installed consistently and safely. Now, let's discuss the importance of ongoing training and education for electricians and other qualified personnel. The NEC is a complex and constantly evolving document. It's essential for electrical workers to stay up to date on the latest changes and requirements. This can be achieved through continuing education courses, workshops, and professional development programs. Additionally, it's important for electrical workers to have access to the latest versions of the NEC and other relevant standards. This ensures that they have the information they need to perform their job safely and effectively. Now let's delve into some common misconceptions about wire marking and identification. Firstly, some people believe that it's acceptable to use any color of wire as long as it's properly labeled. However, as we've discussed, the NEC strictly regulates the colors that can be used for specific conductors. Secondly, some people think that it's okay to use different colors of wire in different parts of an electrical system. However, this can create confusion and increase the risk of misconnections. The NEC requires consistent color coding throughout an entire electrical system. Thirdly, some people believe that wire marking is only important for new installations. However, wire marking is also crucial for maintenance and troubleshooting. Proper wire marking can save time and prevent errors when working on existing electrical systems. Now let's consider the role of technology in wire marking and identification. Firstly, there are a variety of tools and equipment available for marking wires, such as wire markers, labels, and heat shrink tubing. These tools can help to ensure that wires are clearly and accurately identified. Secondly, there are also software programs that can be used to generate wire labels and diagrams. These programs can streamline the wire marking process and reduce the risk of errors. Thirdly, advancements in technology are leading to the development of new and innovative wire marking methods such as laser marking and RFID tagging. These technologies offer the potential to improve the accuracy and efficiency of wire marking and identification. Now let's discuss the importance of collaboration between electrical contractors, engineers, and inspectors. Electrical contractors are responsible for installing electrical systems in accordance with the NEC and other applicable standards. Engineers are responsible for designing electrical systems that are safe and efficient. Inspectors are responsible for ensuring that electrical systems are installed correctly and meet all applicable requirements. By working together, these professionals can help to ensure that electrical systems are installed and maintained in a safe and reliable manner. Now, let's consider the ethical considerations associated with wire marking and identification. Electrical workers have a responsibility to ensure that all electrical systems are installed and maintained in accordance with the highest safety standards. This includes properly marking and identifying all wires and conductors. Failure to do so can create a dangerous situation and put people at risk. Additionally, electrical workers have a responsibility to report any violations of the NEC or other applicable standards. This helps to ensure that all electrical systems are installed and maintained safely and correctly. Now, let's summarize the key points we've discussed regarding wire marking and identification. Firstly, the NEC strictly regulates the colors that can be used for specific conductors. Secondly, wire marking is crucial for ensuring the safety and proper operation of electrical systems. Thirdly, there are a variety of tools and equipment available for marking wires. Fourthly, ongoing training and education are essential for electrical workers. Fifthly, collaboration between electrical contractors, engineers, and inspectors is crucial. By following these guidelines, we can help to ensure that electrical systems are installed and maintained in a safe and reliable manner. Furthermore, it's essential to remember that electrical safety is a shared responsibility. Everyone, from electrical workers to homeowners, has a role to play in preventing electrical accidents. By being aware of the potential hazards and taking appropriate precautions, we can create a safer environment for ourselves and others. Let's consider the long-term implications of proper wire marking and identification. When electrical systems are properly installed and maintained, they are more likely to operate efficiently and reliably for many years to come. This can save money on energy costs and reduce the need for repairs. Additionally, properly marked and identified wires can make it easier to troubleshoot and repair electrical problems in the future. This can save time and money, and it can also reduce the risk of electrical hazards. Therefore, investing in proper wire marking and identification is a smart investment in the long-term safety and reliability of electrical systems. Now let's discuss the specific requirements for grounding and bonding in electrical systems. Grounding and bonding are essential for protecting people and equipment from electrical shock. Grounding provides a path for fault current to flow back to the source, causing the circuit breaker to trip and de-energize the circuit. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault current. The NEC provides detailed requirements for grounding and bonding in Article 250. These requirements cover everything from the size and type of grounding conductors to the methods for connecting grounding electrodes. Now let's consider the different types of grounding electrodes that are permitted by the NEC. Firstly, a metal underground water pipe can be used as a grounding electrode if it meets certain requirements. Secondly, a ground ring consisting of a bare copper conductor encircling the building can be used as a grounding electrode. Thirdly, a rod or pipe driven into the ground can be used as a grounding electrode. The NEC specifies the minimum size and length of these electrodes. Fourthly, a concrete encased electrode, also known as a U for ground, can be used as a grounding electrode. This type of electrode is typically installed during the construction of a building. Now, let's discuss the importance of using the correct size and type of grounding conductors. The size of the grounding conductor must be based on the size of the overcurrent protective device protecting the circuit. The grounding conductor must also be made of copper or other approved material. The NEC provides tables that specify the minimum size of grounding conductors for different circuit sizes. Using the correct size and type of grounding conductor is essential for ensuring that the grounding system can effectively carry fault current and protect people and equipment from electrical shock. Now let's consider the requirements for bonding metal parts of an electrical system. All metal parts that are likely to become energized must be bonded together. This includes metal conduit, metal enclosures, metal equipment, and metal piping. Bonding can be accomplished by using bonding jumpers, bonding screws, or other approved methods. The NEC specifies the minimum size of bonding jumpers for different applications. Properly bonding all metal parts of an electrical system is essential for creating a low impedance path for fault current and preventing electrical shock. Now let's discuss the importance of inspecting and testing grounding and bonding systems. Grounding and bonding systems should be inspected and tested regularly to ensure that they are functioning properly. This can be accomplished by using a ground resistance tester or other approved methods. Any problems with the grounding or bonding system should be corrected immediately. Regular inspection and testing can help to prevent electrical accidents and ensure the long-term safety and reliability of electrical systems. Now let's consider the role of arc fault circuit interrupters, or SIs, in electrical safety. SIs are devices that are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. SIs trip the circuit breaker when an arc fault is detected, preventing the fire from starting. The NEC requires SIs to be installed in many areas of the home, including bedrooms, living rooms, and dining rooms. SIs are an important part of a comprehensive electrical safety plan. Now let's discuss the importance of ground fault circuit interrupters, or GFCIs, in electrical safety. GFCIs are devices that are designed to detect ground faults, which are electrical conditions that can cause electrical shock. GFCIs trip the circuit breaker when a ground fault is detected, preventing electrical shock. The NEC requires GFCIs to be installed in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. GFCIs are an essential part of a comprehensive electrical safety plan. In summary, wire marking regulations exist to protect people from harm. These rules are not arbitrary, but are designed to keep everyone safe and provide a long-term maintainable solution for electrical systems.